Okay, everybody, welcome. I'm David D. Hilster, I'm one of the co-authors of NLP++, and today we have a rare treat. Amnon Meyers, who is the architect of the NLP engine, is going to be talking today to you guys. We were asked specifically by your VP of the Coding Club to talk about this side of things, and I think it's great because it's very interesting. I do know the code myself. If you want to take a look at the code, you can go to VisualText in GitHub, and at the very top left-hand corner, pinned at the top is NLP-engine, and there you will find all the C++ code you'd ever want to know about. That actually builds the engine for all three platforms. I know it probably second most than anybody. It's a quite amazing code, and we're very lucky. And just a reminder, the chances of really having someone talk to you about how they implemented an interpreter and compiler for a language that people are using around the world, that's quite a treat. So without further ado, I'm going to duck out of here and introduce Amnon Meyers. I've known him since 1990. When we met at McDonnell Douglas in Huntington Beach, California. I was tasked to take his Lisp program in NLP on a Lisp machine and port it over to C or C++. I don't remember really which one it was, but doesn't matter. And then from then on, we've had a really productive relationship in NLP, culminating in 10 years later, coming up with the NLP++ language, VisualText, and also integrated the conceptual grammar, which of course is also his doing. So, Amnon, the floor is yours.
So the title of this talk is Compilers and NLP++. We will talk about compiler writing in very brief detail, and a lot of this talk is about my background in academia and how the NLP++ language came to be. So background, my experience in academia, a brief overview of compiler writing, then discussion of the NLP++ programming language and some of its applications. So this overview of my education started at MIT in biology in 1970 to 73, then moved to Berkeley for organic chemistry. Actually, at MIT at the time, they were doing Project Mac, which is machine and computer, or whatever else MAC stands for. I think Marvin Minsky was there. They were doing all kinds of AI work, but I wasn't totally into it at that point. From organic chemistry, I moved to computer science in Berkeley, 1979 to 82. And from there, basically I took all the courses of a professor, Robert Walensky, and based on his recommendations, I went to work for a Professor Richard Granger down at the UC Irvine, California Artificial Intelligence Lab. From there, moved into aerospace laboratories, starting with McDonnell Douglas for about 5 years, and then at TRW Space Park Artificial Intelligence Lab in the 90s. Basically, my family said, well, anytime you want to take this commercially, let us know. So around 1998, I called my father's bluff and said, okay, aerospace is never going to use this language processing technology, so let's make a company. And actually, it started out as kind of a family company. We called it Text Analysis International. And actually, this company existed from end of 1998 to 2018, about 20 years. And this URL is wrong. It should say text analysis
Yeah, I put the
ysys.com.
correct. I put the correct link in the chat. So
Okay, thanks. And following closing of Text Analysis International around 2018, I started a new company called Conceptual Systems, which basically owns the intellectual property of NLP++ and VisualText and conceptual grammar. So this is an overview of my work in compiler writing, starting with compiler writing courses at Berkeley. And basically, I did some research assistant type projects, one for Professor Richard Lipton at Berkeley. I don't know if you know what the APL language is. An APL program is basically a string of symbols, and each symbol represents some kind of mathematical operation, like matrix operations and the like. And APL in general was always in an interpreted language, but Professor Lipton had the brilliant idea of creating this or modifying this to be a compiled version of the language execution. So it was very interesting. It looked like binary code, but every line of the binary code was actually a function call to do one of these mathematical transformations. A second project I worked on was a language called Plain, which basically integrated standard computer programming with basically tightly integrating to a database. So Plain had basically language constructs that addressed database in an integrated fashion with a regular programming language. Let's see. Moving on from UC Berkeley, I went to work as I say to work for Professor Granger at UC Irvine in the Artificial Intelligence Lab from about end of 1982 to 1988. And we wrote they had a program called Nomad, the Naval Onboard Message Analyzer and Disambiguator, basically with a contract with DARPA and the Navy organization called NOSC, Naval Ocean Systems Center, based in San Diego. And so they had a system called Nomad, which did these Navy message processing. And Professor Granger wanted a version of this system or an addition to this system, which would in some formal way add knowledge, add vocabulary, add event knowledge, and so on to the Nomad language. So the idea of Nomad was to process Navy messages like cited, sub, saying same, which could be construed as very ellipted or terse Navy utterances, as you might get from a sailor saying what they saw out on the naval battlefield. Nomad was based on conceptual dependency theory, which was created by Professor Roger Schenck at Yale. And again, the task here was to process ill-formed Navy messages. So I created the VUX system, and VUX stands for Vocabulary Extension System, and rather than just creating a module to attach to this existing Nomad analyzer, I decided to rewrite the whole Navy message analyzer from scratch. And basically, there was a big argument one of the first days that I worked for Professor Granger as to the role of syntax in NLP for English, and the Shankian conceptual dependency idea was that syntax wasn't that important, but I had a very different view, and Professor Granger and I had a huge argument one day, and then I never saw him for the rest of the 6 years, really. I went off and built a new system with a lot more basis in English grammar, as well as conceptual representations for English. And Vox as well incorporated user interface dialogue for adding vocabulary, events, and frames. And the frame might be viewed as basically a sequence of related events, like we saw a submarine, we fired at it, we sank it, and all those wonderful kinds of scenarios. By the way, going back here, the Vox system had a knowledge base attached to it called conceptual grammar, which you may know. Conceptual grammar is also part of the current NLP++ system, but the way conceptual grammar looked back then in Lisp and so on was very different from the kind of knowledge base representation that we use in the current conceptual grammar. So a sample frame in the Vox domain, the Vox naval domain, might be a ship attack ship frame, which would have under it the event of a ship sighting a ship attacking a ship, and then a ship assessing the results of its attack. And if the knowledge base, if the conceptual grammar knowledge base, and if the Vox analyzer were built appropriately, then something like cited, sub, sank, same could be understood as an instance of a ship attack ship frame. The Vox message analysis system, NLP system, served directly as the excuse me, as the cause for the creation of the well-known message understanding conferences. Our relationship between UC Irvine and the Navy down in San Diego led to Glenn Allgaier, the manager there, basically getting the idea of starting a conference to compare various systems nationwide on their performance on these Navy tasks. And this kind of conference differed from every other thing you might see in academia, because people actually put their systems on the line and had to report the scoring of their systems, and these things were compared to each other. So you could actually choose, which system performed best, which performed second best, and so on in each of these conferences or workshops. So everybody was putting their necks out, necks on the line. Quite a unique kind of format for an academic, for a set of academic communities, and actually involved academic entities as well as organizations such as Stanford Research Institute, New York University, BBN. These were all very, very high profile natural language processing entities at the time.
Amnon, could you?
Yes, sir.
I think it'd be interesting for the students to get explain to them how the test sets were made and how the testing went. Obviously, we'd have to do that, but it's a lot different than it was today. Do you remember what us having to fill out those templates, and do you remember that process?
You can talk about it. My memory is not great on those details.
Yeah, basically what was given, every team was given 100 messages, and the idea was to generate the output templates, which was basically it was terrorist, or the one, at least the ones I was involved
Mach
with.
3, yeah.
Mach 3 was terrorist organizations in articles. So basically, you would read an article and you'd say the Mujahideen attacked the city with helicopter gunships at this time in this date. And the idea was what we would be doing is each team would have to generate a test set that would be used for other teams, and then we would have a development set as well. And then at the final thing is that we were then once we've developed our system on the test set, we would then be able to we were given a test set, and that from that test set we would run our system on it, and then that system would be judged with others, and we get a score, and those scores would be ranked. So that's the kind of way it was done. The actual answer keys that we used during this was the keys for the actual scoring and ranking of the systems that were competing. Okay, go ahead, Amnon.
Okay, so David and I were at McDonnell Douglas AI lab at the time of actually Mach 3 and Mach 4. So we built a basically what we called a shell, basically a program that enables a user to develop text analyzers. Basically what we call in it an integrated development environment these days. And David built this wonderful graphical IDE, which embedded our code for, and we actually developed a new language analyzer called Texas, TEXUS, which stood for Text Understanding Shell. And this was all done in, as you say, David, I think C at the time. C programming language. And we were a two-man team competing against a huge group at Stanford Research or New York University, basically, professors and their graduate students spending man years on these tasks. David and I built the Texas system in about 9 months. And David at Mach 3 spent most of the 2-man months that we expended to prepare for Mach 3, and actually we came in about 4th place out of 12 to 15 participants, which was an incredibly good result. Of course, at McDonnell Douglas, if we didn't win the competition, then then that was not a good thing as far as the corporation was concerned. But from our perspective, this was a tremendous result. And none of the competitors believed that we had only spent 2-man months developing the analyzer for these Navy messages, because everyone else spends so much more time. But when you have the right tool, when you build the tool that enables you to do the task, then you basically have a force multiplier and can do things up 5 or 10 times faster than just manual labor, purely manual labor. And so Texas was the first multi-pass system that we had built, a multi-pass or a pipeline architecture. I'm going to talk a little bit about compiler writing, because that is what we are mandated to do here. So, you need a programming language to compile. In our case, there's NLP++ language, which I can tell you more about later. So you're either creating a new language or you're writing a compiler for a new language. And the execution of a programming language can be either interpreted or compiled. Interpreted means the language definition itself is read into memory and executed while the language definition is in memory. Compiled means you convert the language definition to an executable library or executable program. And of course, compiled analyzers, compilers are much faster. So there are various tools and methods for writing compilers, and certainly these days, if you want to know what's currently done, you will simply Google it and see what's out there. For a long time, there have been parser generators that basically you create a set of rewrite rules or grammar rules that define a language. And these parser generators will automatically create a parser for you. And some old versions of these, some are still in use, are YAC, which stands for yet another compiler. Lex deals more with lexical aspects of text analyzers, and there are other variants. Flex is an improved idea for Lex, and Antler and Bison are alternatives to programming language compilers. If you look these days on Google, there's just a huge set of programs that generate parsers for you. Here's a link you can go to. I'm not going to talk about any of these. I actually don't know that much about them. Again, we wrote our compilers a long time ago. So. Now, apparently, even these days, a lot of compilers are hand-coded, and that's in order to make them a lot faster, a lot more efficient, a lot more optimized. One thing not mentioned here is the old Fortran compiler, which apparently is one of the greatest compilers of all time, going back, I don't know, 50 years. And I believe people still use such a Fortran compiler and COBOL compilers and so on in business these days. That was our compiler writing overview. We'll go and take a look at the NLP++ programming language at this point. So NLP++ is a simple C or C++ like language, and we've built it on top of C++. NLP++ integrates standard programming language constructs with grammar rules or rewrite rules and the associated actions once you match those rules. Also integrates a knowledge base, a hierarchical conceptual knowledge base called conceptual grammar, and integrates parse tree constructs like the nodes of a parse tree and their attributes. NLP++ also enables a integrated pipeline of passes, where each pass has its own algorithm, rules, and code. And the NLP++ passes contrast with what other people do out there. Basically, people will take a lexical analyzer, a parser, a semantic system, and each of those would be a black box, and they would string these boxes together. Whereas with NLP++, these passes are completely glass box. You can modify and enhance any of them. You can insert new passes into the pipeline as you need to. And the passes communicate with each other via the knowledge base, via the parse tree, via global variables, and so on. And the NLP++ language itself is extensible. There's a project called the user project underneath the general analyzer project, where you can define new NLP++ functions using C++. So again, the alternatives that you see out there are typically black boxes from multiple sources, multiple authors. They're not really built to work together. They have to be, there have to be interstitial code to make these different black boxes work together. And systems like Core NLP and Gate are examples of these black box pipelines. And what you see is with each box, overall accuracy decreases. If each box is 90% accuracy, well, you put three of them together, you're going to end up with 90 times 90 times 90, which is about 73% accuracy at best.
Amnon, we do have a question I'm looking at. I think it's a good time to answer it. One question is there any specific reason for choosing C++ for writing this?
No particular reason. I mean, it's just been an industry standard for many applications. And
yeah, I think, I can kind of answer it because when I was starting NLP right out of college, we were using C. And the reason we used C at the time, and then later C++ became more prominent, because it's fast, it's compact, it writes the, other than assembly code, which is a level below it, it's probably one of the most efficient languages. Now, I think today they have R or something like that, and people have asked us about could the NLP engine be rewritten in R? But the idea is that C++ is a lower level, more efficient language. So you're going to get a better, faster running result using C++. So I think that, and then NLP++, the name kind of came from that kind of same genre, again, 25 years ago. Okay, so that answers. Let's see, here's another one. How much of automata theory was used for this?
Zero.
And I think I can talk a little bit on this myself. When I was going back and just a couple of years,
David,
I'm sorry,
you cut out a little bit there. Go ahead.
Okay, I'll try again. Sorry, the connection here. But when I was putting in, for instance, Unicode and emojis, which was a pretty big task to put into the NLP engine, and I was really looking at it, I myself was curious about using another compiler language, compiler rule system. And then when I did some research and I looked at it, you saw that one table that we had with C++ near the top, and you saw that all of the major languages are written basically by hand. And the reason is, and this is just my take on it, is that when you are using these compiler languages, the amount of specialized stuff you'd have to do around the system of simple code, simple rules that you would write in Yak or something like that, the amount of having to work around the simplicity of those compiler languages gets to be so difficult that it then becomes less useful than more useful. So I think that's the reason you see no one doing that, is because for you to have somehow a compiler language that could be used for all computer programming languages, it just becomes almost, I mean, it becomes almost impossible. To give you an example of what I see with the NLP++ that Amnon had to deal with is strings. I mean, you have text, and a lot of it, you have to have structures that hold these texts and build them and release them. It's C++. It doesn't happen. Garbage collection is not automatic. But there's so much involved with the language itself, not just the parsing of it to get what the language is written, what you then do with it, that it just becomes untenable to try to use a simplistic compiler language for something like this. And that's why you see all the major languages, Python, C++, C, all of them basically having just plain old hand-coded computer code to write their compilers and interpreters. So I hope that answers that.
So, again, this slide is talking about comparisons of NLP pipeline architectures, everyone else, let's say, versus NLP++. And I talked about some of these differences, that our passes are all written in the same language. They're written to work together from the get-go, from the beginning. And they work synergistically to construct a single best first parse tree. The passes are glass box. All the code is visible, can be edited, modified, enhanced. And one of our customers called this model the pancake model, because you have a set of passes. Each one does some work of the analyzer, and if you need something additional, something new, you can stick in a new pass anywhere within that sequence and do the processing for that pass. Just a cute name. So NLP evolution. So, David Hilster and I basically created the NLP++ language ideas, the idea of a multi-pass system. David brought an idea of the rule matching algorithm would go left to right as well as right to left. In other words, you'd start with matching some initial node or initial piece of text, and then you could go, the parsing algorithm or the rule matching algorithm could go left from there and right from there, or both simultaneously. So sort of an island driven rule match algorithm. I brought in the knowledge base, basically. But David built the VisualText GUI integrated development environment, which was and still is an incredible piece of work, and it can be downloaded out there from the textanalysis.com website. Whereas I was tasked with implementing the language itself. And initially, basically the language consisted of rewrite rules, and when you match, when noun verb noun matches a piece of text, well, you need to take some kind of actions to record that. Oh, now I've got a sentence. Actions to build the parse tree and record semantic information. So actions were added later on, and further on, the first versions of NLP++ didn't even allow a user to write functions, and that came a few years later. And even now, not all actions, things that are called actions, are actually more limited in some sense than the kinds of functions that users can write, and the kinds of functions that are built in to NLP++. So And again, NLP++ is like a regular programming language, except that it also addresses parse tree and knowledge base objects in an integrated fashion, just seamless part of the language. So here's an example of a NLP++ pass file in the pipeline architecture. One thing you'll see here, well, we could start at the top, and each pass file in general starts for the code region, in which you can put in code that precedes rule matching. This node's text zone line means that you're going to match underneath, immediately underneath a text zone in the parse tree, wherever it occurs in the parse tree. So basically, this directive sets the context of where rules are going to be matched in this pass. And then you have this rules area where you actually write the rewrite rules. Here's the rewrite rule arrow. These are wildcard entities that either fail on a new line token or and until you find one that matches an end of sentence token. So you're matching things till you reach an end of sentence, and maybe you'll find some punctuation characters after that end of sentence, and all of that will become a sentence node. So non-literals have an underscore. So underscore sent means it's a non-literal sentence node that this rule match, this pattern match is going to build. Once a rule matches, you execute the actions that are above it. In general, there are precondition actions, there are checking actions to make sure that you want to actually match the rule, even though it looks like it matches, just constraints. And then once you accept a rule match, then you enter this post region. And this is what NLP++ code looks like. The main difference between NLP++ and other languages like C or C++ is that a variable looks like a letter, letter followed by the name of the variable, followed by optionally some kind of context. So what this one says is, I'm looking at node number 3, 1, 2, 3 in this pattern match, and I'm looking to see if it has a variable called sentence end, and if it has it, then I'm setting the sentence itself to get that same sentence end. Anyway, so basically variables look different, but functions look the same, and mathematical operations look the same, and so on. So the only funny looking thing is actually the way you designate a variable name. And this lets you put arbitrary text inside the name of a variable. So kind of convenient. And David has this beautiful highlighting for the code itself. You'll see that, and this all comes from the old VisualText GUI. You'll see similar in the newer version, which runs in VS Code, the NLP engine version that David implemented. Okay, so the NLP++ integrates a conceptual grammar knowledge base, and the basic unit of the knowledge base is a concept. It's a hierarchical knowledge base with a concept called root at its base. Each concept has attributes like string valued, integer, float, and so on. And a pointer attribute can link concepts together, so that the knowledge base can actually represent a general graph rather than on top of the hierarchy backbone. And these are just notes that the old VisualText GUI, which again is downloadable for posterity or whatever, differs from the one that David created under Visual Studio Code, VS Code. And there's some differences in permanence. The NLP engine version doesn't yet compile analyzers, which is something you could still use the old GUI for, compiling analyzers and compiling knowledge bases to C++. Some more about the conceptual grammar knowledge base. There are specialized sub-hierarchies that typically come with a conceptual grammar knowledge base. There's a system internal sub-hierarchy, and there's a dictionary sub-hierarchy where when you add a word, it automatically goes to a place that's indexed, or there are hash tables that enable fast lookup and so on. There are ad hoc sub-hierarchies that, for example, typically one builds a phrase lookup hierarchy these days, and there are domain sub-hierarchies like ISA hierarchies. A line is an animal, is an object, or whatever. Currently, no version of the knowledge base supports pointers from the knowledge base to the parse tree, because parse trees are ephemeral. They disappear after the text is gone, but the knowledge base is permanent in the sense that you can gather information across multiple input texts that you analyze within a knowledge base, make them as permanent as you want.
I'd like to interject here.
Yeah.
Actually, I actually did this in code. Basically, yes. What this means is, if you have a tree that you're parsing, the text comes in, you're making a parse tree from that, and you have a knowledge base. And oftentimes when you're building an NLP++ analyzer, it's going through reading stuff, and you're building knowledge as you go. Well, I did implement a system in some functions called tree funcs, and basically what it does is very interesting. You can label the parse tree with an ID, and that ID is a concept, and then that can be looked at and saved in the knowledge base. So I believe that may be in what I'm going to show you tomorrow, but again, it may just not mean a whole lot to you, but there is a way for you to do that. There are some reasons why you may want to do that, but I've done it in functions. In fact, a lot of the reason we don't add a lot of functions to NLP++ is because you can make functions in NLP++ that are extremely useful, and it's probably the most efficient way to do it. But you can, there is a system that that I developed just recently that allow you to do that. Actually, just put an ID on a tree, and if it goes away, it's just not there anymore. So always new things coming up. Go ahead, Amnon.
Yeah, actually, so there are other differences between the old GUI and the new NLP engine. So David has implemented basically dictionary and phrases are an integral part of how he specifies a knowledge base and a knowledge base file. And the old methods use a sort of command line architecture for representing knowledge in the conceptual grammar, but David has files that are much more human readable. Basically, it's like the hierarchy is just an indented set of lines, and the greater the indentation, the lower down in the tree the words and the phrases are, and phrases are actually integrated into David's method in a simpler way. I would argue that you still may want some other. So David's phrases are so when you tokenize in the first pass of a text analyzer, phrases are tokenized as well. Phrases are recognized as well in David's version of the NLP engine. And that is not the case in the original visual text version of NLP++. Anyway, these may not mean much to you, as David says at this point, but there are implications for how phrases and the dictionary are handled. So, I showed you the example of a pass file, and we can just talk about that more formally. So an NLP++ analyzer consists of a sequence of pass files, basically a pipeline architecture. There's an analyzer sequence file that basically lists the passes by name, and each pass that gets its own algorithm. For example, a recursive parsing algorithm versus a one-time through or regular pattern matching algorithm. A pass file can contain these regions, a code region, as I showed you, that executes prior to rule matching. Then there are descriptors that specify the context under which the rules will match in the current pass. So path says, well, you start at the root, you go down to a node, you go down to its child, and so on to the place. Like, say, you start at the root, you go to a paragraph, then you go to a sentence. And if you want to process at the sentence level, you just specify that with your path. So each pass can go and revisit different parts of the parse tree. It's nothing like a recursive grammar in that sense. In other words, you can go or you can have multiple recursive grammars at specific locations in the parse tree. Incredible flexibility is enabled by this multi-pass methodology. The rule regions can repeat inside a pass file, and again, you have these preconditions, these checking code. Preconditions are sort of a hardwired syntax for making sure that that the nodes in the text that you're trying to match will conform. And check lets you write more NLP++ code, basically regular code to do checking on the rule match. The post actions are the code that follows when a rule matches. And then the rules themselves, these regions can occur to a number of rules, and then if you want a different action for some rule, then you create a new rules region with all the checking and post actions that accompany that. So as I've said, these syntax of variables in NLP++ is the main obvious difference that you'll see when you look at NLP++ code. Once you get used to that, then and the reason that variables look different here is you have so many different contexts. You have global variables, you have local variables to the current set of rules that you're looking at. You have variables that address the parse tree nodes themselves in the rewrite rule. So element 1 of the rewrite rule would be N1, and so on. The X variables are ones that let you address the nodes in the context. So if the context is you've got the root, you've got the paragraph, you've got a sentence, then X3 might be the sentence down in that path. So you're saying, I want to modify the current sentence node of the parse tree with some semantic information based on a rule match. And the S variables are for suggested, so you have a rewrite rule, and the suggested concept in the rewrite rule, you want to put information on that. So you have all these different contexts that you need to address. That's why, it's not just global versus local like you might have in a regular programming language. You have all these different contexts in the parse tree, in the knowledge base. And there are no variables for the knowledge base itself, but these things like local variables, global variables, and so on can address the knowledge base as well. They can have point concept values. In other words, and in that way, you can add information to the knowledge base. So NLP++ is a loosely typed language. That means that the same variable can point to any data type. And arrays can mix arbitrary data types as well. So variables don't have a type declaration. And when you don't need to initialize variables, they're automatically initialized to 0. And this flexibility has advantages and disadvantages, certainly. Checking on program correctness. You may have the wrong variable value in some cases. You might think you're dealing with a concept, but you're actually dealing with a parse tree node. So you have to be a little more careful with this added flexibility. So NLP++ can be interpreted or compiled. And as I say, compilation not yet turned on in the NLP engine version. The code is all in there. And compiling actually consists of converting the NLP++ code to C++ and then using some standard C++ compiler like GNU C++ or Microsoft Visual Studio C++ to do the actual generation of compiled objects, libraries, or programs. And the original GUI can be used to convert the code to C++ during the load of an analyzer. I would caveat that if you're writing NLP++ analyzers in the NLP engine, they won't exactly work within the old VisualText GUI, mainly because, again, dictionary and phrases are treated very differently. So I've actually written, going back here, I've actually written, when I bring an NLP engine analyzer back to compile it, I have some things that take care of the differences between phrases between the two versions of NLP++. And the interpreted version of NLP++ is done analogously to other programming language. Supposedly the good programming languages compile themselves, use some simple version of the language, hardwired to read the full version of the same language. And we've done the same kind of thing. There's a simple version of NLP++ hard-coded into the NLP++ runtime code. That's called the rule file analyzer, and that parses an NLP++ definition. Basically, it analyzes a set of passes that define the NLP++ language itself, and that's called the rule file analyzer version B. And that full NLP++ language is loaded in an interpreted fashion into memory, and that is what processes the NLP++ analyzer code that you write. So it's kind of crazy. It's like 3 levels of indirection. I think David kind of went crazy when he was trying to figure out what I had done in this regard. Okay. Basically, parsers parsing parsers that parse parsers, and so on. Okay. The conceptual grammar knowledge base can similarly be loaded, interpreted, and compiled. And when you compile a conceptual grammar knowledge base, it basically becomes a library that loads instantly, whereas interpreted may take some time to load if it's a big knowledge base. So looking at TAI history again, TAI was around for 20 years, from about 1999 to 2018. And we were always a small company, but probably about less than 10 people at the absolute max when it started out. We had more business people and a few programmers, but we had world-class customers like IBM Global in the UK, and for a bunch of years they used NLP++, and they actually built the analyzers themselves. We never saw them. For a few years, we had NASDAQ as a customer for sentiment analysis. Educational testing service. One of our programmers actually went and has since become a very high-level manager at Educational Testing Service. And he insisted they use NLP++ on a question generation project, multi-year project of theirs. There's a company called Michael Page that built resumes. We had an initial resume analyzer, one of the first clunky things we had built before NLP++ even had functions in the language. But they took that and they kind of, they reused it to build resume analyzers, job resume analyzers for various languages. We had a multi-year collaboration with another company, and the collaboration was called Zio, where we processed deeds, mortgages, other real estate and court documents, basically 100 other types that were presented to county clerks in the United States. So the county clerks received documents, and then they basically imaged them. And so to access those documents, we have to OCR those images. And some of those images are very dirty. The OCR text, readable text, can be extremely dirty. I'll show you an example of that. Anyway, and this was actually implemented as well. These systems were deployed in various New Jersey counties, county clerks, in order to get the information out of these documents. Another example is shipindex.org, where we processed historical documents to get ship information. And a ship name can be absolutely anything, which made it, the Boston sailed into Boston, or kinds of sentences you might see. So this is an example, again, in the old GUI, which is where this was built, of the Zio OCR text analyzer. So here in this pane, you see what one of these text documents looks like. So you've got crossed out text, you've got text at an angle, you've got handwritten text. Sometimes signatures will overwrite text, and these bar graphs also come out funny once you OCR the text and make the characters, converting this to readable characters. So this thing was converted by some other process, OCR process that we did, to this kind of representation where each line is one blob of text from this original image. So here it says acres, land, post office box 769. You might find that in here somewhere. And each blob of text from the OCR'd image has pixel offset information, width, height, left, right, width, height, and so on, and also quality of the, some assessment of the quality. Is this 80% okay? This piece of garbage, this piece of text, and so the text analyzer that I built for this application basically take these OCR documents, get real estate information out of them. So this is the parse tree that's produced from processing this document. This is the kind of developer's output that was produced. So there's a mortgage. The person doing the mortgage is Christine Quinn. The reverse party of the mortgage is Mortgage Electronic Systems and Everbank. The address of this party, the date of the mortgage, and so on and so on. All this was the kind of output that was being sought after. This analyzer we spent about 7 years working on and supporting while it was deployed. It has about, if you look here, it's got 267 passes. You're only seeing the last batch of them from about 230 on. It's got about 250 functions. It's got about 11,231 rules, rewrite rules. So these things can go pretty big. I don't have knowledge base size statistics, but there was a lot of knowledge about different document types, the different titles and attributes of various document types. Again, there were about 100 document types that the system had to know about. And the hardest one was certainly mortgage. Well, mortgage and deed, and there were incredible variability in these documents as well. Anyway, this is just one project, and typically for one of these projects, you might write 60 NLP analyzers, NLP++ analyzers, just to support the main analyzer to do various, development tasks like work on a corpus set or things like that. I'm pretty much done here. We've introduced the history of NLP++ and the VisualText IDE, talked about compiled versus interpreted NLP++, talked about the conceptual grammar hierarchy and some applications within the old Text Analysis International company, which was around 20 years. And we can take questions if you like.
Yeah, well, thank you so much, Amnon. I'm going to make a couple comments here because one of the things we get as reaction from students, or I've seen it on the internet all over the place, is that when people use Python, if anybody here has used NLP, it's probably tools from Python or something like that. You know, the NL toolkit. Let me get myself up here too. Sorry about that. Yeah, the NLP toolkit, or it's going to be something like some other machine learning that everybody would grab and use. And there's two things that kind of happen, and that is one is you use it, you do maybe a little project for a class, where you try to do some type of proof of concept. Then after that's done, you go on. And so your NLP career as a computer scientist will be kind of using these things, using machine learning, like a sentiment analyzer. So you get data of already a trained set, and you run it on something, and then you make this, presentation, you make your project. You can even do an internship like I have mentored many actually from your university, and you do it and it goes on, and it can't really turn into something real. The difference though is that they see something like core NLP, and what the what most students say, and I remember my interns from your university having to fight with people in your club, in your community, is that, oh no, this is not, this isn't computational linguistics, and yes, machine learning can't do these things, and yes, these tools will result that they're not used. NL toolkit at most is probably used in some gaming type scenarios, for somebody making some simple game stuff. It's just not used out in the real world. Whereas the interns that I work with, those people were using NLP++. Sentiment analyzer, to give you an example. That sentiment analyzer that person wrote and got a paper and published and all that, that can be augmented to be very good in a very short amount of time. And that can be used in real life. Why? Because it's 100% code. It's 100% viewable. The other thing people said is like, oh, core NLP are for computational linguists. We programmers don't get into that. This idea that programmers aren't in that realm and that they're going to use generic tools to do stuff is an absolute falsehood. Generic tools don't work. Every time, every student I've talked to, when they've built an NLP++ analyzer to do a specific task, they tell me very clearly, this can't be done generically. So what does this all mean? First of all, these people, all of the people who use NLP++ in all the universities I've worked with in the last 2 or 3 years, all of them are programmers, regular programmers. And if you look at what Amnon was doing with that document, looking at it, he's not doing, oh, go grab a tokenizer, then get the sentences, then get the entities out, get the dates out, and then put them all together, package them all together, and in 12 lines of Python code, the answer comes out. No, because they're specific. Every task is specific. And the problem is, both with industry and in universities, is people think that NLP is going to be packages you just grab, use, get your information, and go on. It isn't true. And what's really great is NLP++ is they're starting to recognize that. And what it does, you don't have to be a linguist to do it. Nobody who was using NLP++ in these internships were even an NLP person. So let me give an example of how I won something and did something no other programmer could do in my group. I was with probably one of the smartest groups I've ever been in, and that is the supercomputing architecture group. These guys, I mean, they came in the beginning of the company before I was even there with IQ tests. I mean, that's how high these people were kind of looked at. And when somebody said, the VP in a meeting that we had at a conference, look, documentation person, we are going to use our documentation. It needs to be translated to Portuguese for Brazil. We need to go through all 1,300 documents and mark where in those documents we don't want translators to translate, right? Well, that sounds like an easy problem to do if a person looks at it. Yeah, don't translate code. So if it's got a word that's English, it's a name for the ECL language, which is the supercomputing language. You don't want to do that. And I sat down with a documentation person, and he gave me all these rules of thumb to go through these documents. That was the end. But going back to the story, he asked the documentation person way before all this started. He says, "Hey, we need to do this. We got to mark no translate with tags in 1,300 documents." And the documentation person said, "That's impossible." And the documentation person was a decent programmer. He says, "It's not done. He's going to have to do by hand." He says, "How long that's going to take?" 700 hours. So I raised my hand because I have NLP++ in my back pocket. NLP++ does any type of processing. It's not computational linguistics. When we humans do stuff, that's a very common thing we'll do. We'll go through all these documents and we'll have some rules of thumb where we know it's very specific to those documents. So there's no generic solutions out there. And I raised my hand and I looked the VP right in the eye and says, "I can do that." He says, "How long would it take you?" Maybe a couple of days. No one believed me. No one believed me. And so I went back and I ran it. And get this is what happened. So I go back and I write the analyzer. It wasn't too hard. And then I ran it all the documents. I had to go through a couple of iterations. This is less than 16 hours it took me to write this. And it wasn't linguistic in any way. It was words, it was documents, and this was a markup language for documentation. So they have their own, I think it's called BookDoc or something like that. And I ran it and I came back to the guy. He says, "You got it done?" He goes, "Yeah, but I found 12 documents that look like it's been edited by Word." He goes, "No way." He says, I've been in charge of documentation since this company started this. There's no way, no one has ever edited anything in Word. Well, what happens when you build an NLP++ parser to go in and look at these things? These people, what you end up finding is way more about the actual data that you're actually processing, and you find problems in the data. And he said, "You're gonna, I found these. I know it because I know the characters that are in these because my parser failed here. When I failed, I looked at them and go, what's going on? Well, we didn't expect these funny characters that Word inserts into these documents." Again, he swore up and down. So I gave him the files. He super mad at me, goes back to his cubicle, and he comes back about a half an hour later and he goes, "I have to apologize. I said there were no, but these are absolutely somebody edited them with Word, and I found those errors. Not only that, I decided while I was doing it, I'm going to write a little parser in the middle of this for the ECL language, which is like NLP++ is to natural language processing, ECL is to the HPC systems. And I went in there and I found all kinds of syntax there. I said, this won't run. So I ran the parser on top of that. So in a meeting I had, having NLP++ in the back of my pocket was not, they don't use it regularly. I just happen to know it. I ran it, did this, and I converted those things. And it took about an hour and a half to run across all those data because they're big documents. It wasn't compiled. It doesn't matter. Who cares? I mean, I was working in HPC system supercomputer where I was pulling in 9 million records a week, with billions in petabytes worth of stuff. So that wasn't, so there's an example of a real world problem that they could not really solve. And I could solve with NLP++, because NLP++ can mimic anything humans can do with language. It's not reading text and putting out full blast entity recognition always. You may be just looking for, I'll show you tomorrow. I hope you do come tomorrow. In fact, Amnon, if you could show the slides, there's a slide in there and you could show, I want you guys, if you are here or you have some of your colleagues, give them this link. Are you there, Amnon?
I'm there.
Yeah, could you show your slides again? And there's one slide near the end that has fix. Anyways, I'm going to put it in the, yeah, he's going to try. But I'm going to show you tomorrow, and I'll answer one more question. I'm going to show you tomorrow. If you go to fix.nluglobe.org, and even if you're on a telephone right now, you can go to it and look at that. Just go to that. I put that in the chat now. And you're going to see 3 analyzers. The second analyzer is one that takes a formatted, go down. Go down, hold on. Yeah.
I gotta find this thing.
That's okay. Anyways,
I'm going to
the other way, the other direction.
Other way?
Yeah.
Yes.
There it is. I put it in. Okay.
I see. I'm sorry. Okay.
So before Friday, tomorrow, go to fix.nluglobe.org. Take a look at those 3 analyzers. They are completely just fake. That is, you click on things. Believe it or not, I wrote an NLP++ or analyzer. Take NLP++ code and color code it into HTML color code. So it's basically just coloring it so it looks nice. And I think I wrote Express. It's in TypeScript Express Python Express, or no, TypeScript Express server. So that's why you see it go to, it'll translate to the port 3000. But in there, the second analyzer is something I think every program has probably come across, and that is a formatted document that has been dumped to ASCII. And that's all you have. So how do you know that the 3 words on this line in this dumped format, previous dumped ASCII file, formatted file from Word or PDF or something like that, that you cut and paste, that you've got things in there that are headers, and you've got the end of a paragraph. So how do you know what is prose? Prose, we say in linguistics, is just text. People are writing text like, hey, hello, how are you today? I'm fine. That's prose. How do you know the difference between 3 lines 3 words at the end of a paragraph that's prose from three words that are header. Well, if you had to program that, you're not going to. It's just really impossible. This gray area. Go through 1,300 text files and mark the do not translate. Can't do it. What are you gonna? You can't do it. It's too hard. NLP++ allows you to do that. And then once you get that in your back pocket, you're going to be able to take data that you can't get at normally. You're going to take web pages and you can't get with beautiful soup because it just is that. Or you can do as some of the students at your university did in one of our intern projects, is to start parsing the Wiktionary pages that are just full of different human beings, put them together. You can't write a compiler for it. It's just, you can't do it. You can't rely on necessarily the formatting. So it's pretty complicated. And this is the same one. If you were here yesterday, I told you the story where they came back and said, Mr. D. Hilster, we couldn't parse these Wiktionary pages without NLP++. These people are not they are not NLP people. They're not computational linguists. So you can do it. If you have files, or you have regex, or you have files that are not full-blown NLP, but I can do it by my rules in my head, that's what NLP++ is for. This is why your university is looking to offer this as a course in August, because in my opinion, every programmer should have this. Why? We all come across text that's kind of got data in it, but we can't get at it because you can't use a compiler, you can't use regex, it's too hard, and you can't do anything. But with NLP++, you can do it. So I'm just want to emphasize to you, this is not something like, oh, yeah, well, that NLP++ guys, it's just like, they've got their NLP plus Python package. No, it doesn't do anything. It just runs an analyzer. You build it, but it runs it. But what the difference is, you don't have to be a linguist to do it. It's not one of those things, well, I can't do it. Yes, you can. And what it does is it opens up an entire group of text, free-form text, or even semi-formatted text that gets you, that makes it look, that makes you be able to process something you cannot. It says, maybe I'm too much of a beginner, but NLP++ looks like a steep learning curve. Let me answer that. We had a person who found us a bunch of years ago, and he was in business, never coded in his life. He couldn't write a Python program. This guy within a month was using NLP++. Why? Because NLP++ requires you to think like a human when you look at the text. I'm looking at this text. I've got to do this kind of operation, and I need to know about this and all this rule and that rule. Well, everybody is a native speaker of one or more languages. You are an expert at it. What you do with NLP++, you take the text, you look at it, you start writing dictionaries for it, which is just basically typing a word and then attributes with equal signs. It looks them up for you automatically. You want to write a rule. Rules are really easy to write. In fact, you can sweep on stuff and it'll generate a rule for it. Once you get the idea, it's just match this and match this and match this. And then you do it in the first pass. You do dates, then you do sentences, then you do etc. So the learning curve, believe it or not, the learning curve for NLP++ isn't the language itself. It's getting people to think like humans. Remember the rules I said yesterday. There's 2 rules to NLP++. It's not like regular programming, which is think like a computer. That's what you guys do. That's what all you guys do. You're really good at it. But what NLP++ is, you got to think like a human. Second rule of NLP++, think like a human. Once you sit down and look at the task and in your mind, describe what you need to do. Well, you're going to need some vocabulary. Yeah, I look for these words and they all mean this. So you start building your little dictionary for whatever that is, Then you go through and, I find these patterns, and then I can build those up. It's more of thinking about how you do it and then encodifying it. So the biggest problem I had was getting people to think like humans. And so that's really the obstacle. The language itself, we've had non-programmers use it because they know text. They know, one of the things I do is go write a date analyzer with NLP++. Well, you go right click in the KB, and we've got English, we've got Portuguese. You just right click and you put the dictionary there and say dictionary tokenize. It's going to look at everything up. And so the first thing it does, you got all the months there, and it's got the month, it's got all those attributes with the month in the tree itself. So if you have February, FEB, you have that dictionary, which you right click and just put in, it's already there for you. Then it's marking that word already in the tree as a month, month 2, and so you can see it's that is what you're doing. It's not the language itself. And once you get a hang of it, it becomes very natural. So it takes a little bit of time. Says there are Amnon says there are YouTube tutorials. And also, if you are interested, take advantage while you can, because as this gets more and more, our goal in 2025 is we're going to launch this in a bigger way. That's what the fix.nluglobe.org is part of. This is you're getting a little idea of how we're going to launch this. So I would recommend everybody here, go in, give it a try. Just go to the Fixed, click around. Don't be worried about, I can't do it because it's all linguistics and I can't do matching and it's really complicated. No, think of a task, sentiment analysis is good, and then do it. Tomorrow, I will be talking to all of you about, showing you these 3 analyzers that you'll see in fix.nlp globe. You go there onto that web page and you click around, watch my little intro. I'd say, look at the intro video. It's only a minute and something. Then once you've clicked around and looked at it, then if you click on try, it'll go to a web page, which then will show you, I have a 4-minute video, how you can download it and get these things and start playing with them on yours. Just play with it, click on it. You'll get the idea pretty quickly.
Yeah, best to look at it before tomorrow.
Yeah,
presentation, actually. Yeah.
Right, and I will let
questions.
Right, I will let that and give that information for everybody to hand on to your club. So, anything else? Anything else there? Well, thank you so much, and thank you, Amnon, for presenting. And listen, you guys, how many people have you ever talked to or heard that has been involved in building and in designing a new programming language? Huh? I've known one is all. So that's pretty cool. That's pretty cool. So thank you so much, Amnon. I'm going to stop the recording. This will be available. So those people who came in late, you'll be able to get the recording. And we hope to see you tomorrow. So.